Hello dear students, this is your Engineering Mathematics 3 lecture. Here we are going to discuss few examples on normal distribution, normal probability distribution. In last lecture also we have discussed normal distribution and few examples on normal distribution. Now here in this lecture again we are going to discuss the examples on normal distribution. This topic is from 4th unit, normal distribution. See the example. In a certain examination test, 200 students appeared in a subject of statistics. Average marks obtained were 50% with standard deviation 5%. How many students do you expect to obtain more than 60% of marks, supposing that marks are distributed normally? See, no question. In a certain examination test, 200 students appear in a subject of statistics. Now the average marks obtained were 50%, means the average the value of mean is given, it is equal to 50%. See, write in solution, mu is equal to 50%. 50% means 50 upon 100. So you simplify this 50 upon 100 and the answer is 0.5. So the mean is 0.5. The average marks obtained were 50% with standard deviation 5%. Standard deviation means the value of sigma is 5%. 5% means 5 upon 100. You simplify this term, it is nothing but 0.05. Okay. Then writing the value of mean and standard deviation, how many students do you expect to obtain more than 60% of marks? To calculate how many students do you expect to obtain more than 60% of marks. Now here you assume that x1 is 60%. x1 is 60% means 60 upon 100. Simplify this term, it is equal to 0.6. Okay. Now we have to calculate how many students do you expect to obtain more than 60% of marks, supposing that marks are distributed normally. So it is obvious that it is an example of normal distribution here. Now after writing the value of x1, now you convert that x1 in terms of the z1, and the formula is here, z1 is equal to x1 minus mu upon sigma. Z1 is the standard normal variable. Now put the value of x1 is 0.6, mu is here 0.5, and sigma standard deviation is 0.05. If we simplify, it is equal to 2. Now see, what is the question? How many students do you expect? How many students do you expect to have to obtain more than 60% of marks? Means when we want the probability x is greater than or equal to 60%, greater than 60%, more than 60% means x is greater than 60%. 60% means 60 upon 100 means 0.6. Find the probability when x is greater than 0.6. When x is greater than 0.6, we have converted x in terms of z. So you find the probability when z is greater than z1. So z1 is 2. Now how find the probability when z is greater than z1? Now you draw the diagram. Here the value of z1 is plus 2. So that z1, it lies in RHS side of the normal curve. Here is z1 is equal to 2. Now we want the probability when z is greater than z1. Z is greater than z1 means you find the probability of this shaded portion. Probability means you find the area of this shaded portion. This is nothing but the probability when z is greater than z1. Now how to find the area of this shaded portion? You know that here the right side area, complete area, this is a normal curve, and this z is equal to 0. It divides this normal curve into two equal parts. So the half area is 0.5. RHS side, this complete area is 0.5. We subtract the area of z1 from that 0.5, then you will get the area of shaded portion. So your formula is here. Probability of z greater than 2 is 0.5 minus area of z1 is equal to 2. Now you calculate the area of z1. Z1 is equal to 2. You can calculate it from the normal distribution table. Here it is normal distribution table. Z is equal to 2. 2 is here 2.0. The value is Z1 is equal to 2. This you find in 2.0. And the difference is also of 0 because the value is integer 2.0. So you find in the first column, difference in first column is 0.00. So in difference is of 0. So you find the area in 2.0. 2.0, difference is 0. So the area is 0.9772. This is the area. You subtract 0.5 from this 0.9772. Every time we subtract 0.5 from the every value, because it is the table, we have to subtract 0.5 every time. So subtract 0.5 from 0.9772, and then you will get the area of Z1 is equal to 2. So this is the area here. Area corresponding to Z1 is equal to 2 is 0.4772. And so you put here the value of area of Z1, 0.4772. You subtract from 0.5, and so your answer is 0.0228. This is the probability probability when Z is greater than Z1, and this is the probability when X is greater than 60%. Now we have to find out the number of students expected to get more than 60% marks out of 200. So you multiply this probability value by 200, and if you multiply it by 200, the total is here 46. So 46 students approximately expected to get more than 60% marks. This is the answer. Now next example is here. In a sample of 1000 cases, the mean of a certain test is 14 and standard deviation is 2.5. Assuming the distribution to be normal, find how many students score between 12 and 15, how many score above 18, how many score below 8, and how many score exactly 16. There are 4 sub questions in question number 3. There is a sample of 1000 cases. The mean of a certain test is 14. Here the mean value is given. This is the example of normal distribution, because assuming the distribution to be normal, here it is mentioned. So it is the question of normal distribution. Here mean is given, it is 14. So right here mean is 14 in solution. And standard deviation is 2.5. So the value of sigma is 2.5. And in a sample means the number of trials are here, n is equal to 1000. Now, the first question is, how many students score between 12 and 15? Means here, you assume that how many score between 12 and 15 means you find the probability between 12 and 15. Means your x1 is here 12 and your x2 is 15. So you convert x1 and x2 in terms of z1 and z2. Now what is the formula for to calculate z1? It is x1 minus mu upon sigma. You put here the values of x1, mu and sigma, and simplify it. It is equal to minus 0.8. All the values are here mentioned. Mu is here, sigma is 2.5, x1 is 12, x2 is 15. So you can calculate this z1. Also you can calculate z2. This is x2 minus mu upon sigma. Put here x2 is equal to 15. Here consider x2 is 15, mu is 14, and sigma is 2.5. Simplify it, and the answer is 0.4. So z1 is minus 0.8 and z2 is 0.4. Okay. Now we want the score between 12 and 15, means find the probability between 12 and 15. We have converted that 12 and 15 in terms of z1, z2. That we have considered 12 as x1. And we have converted it in terms of z1, its value is minus 0.8, and we have converted x2 in terms of z2 to 0.4. So you find the probability between z1 and z2. We are going to find the probability between 12 and 15. It means we are going to find the probability between z1 and z2, where z1 is minus 0.8 and z2 is 0.4. And that z1 is negative and z2 is positive. So draw the diagram here, the normal curve. See, z1 is negative minus 0.8, so it lies in LHS side of the normal curve, and z2 is equal to 0.4. It is positive, so it lies in the right side of the normal curve. Now we want the area between these two, area between z1 and z2, because we want the probability between z1 and z2. So area between these two, one is positive, second one is negative. One lies in LHS side, one lies in RHS side. So the area between these two is, you just do the addition of area of Z1 plus area of Z2. This is the formula. And what is the area of Z1 and what is the area of Z2? You can find the area of Z1, Z2 from the normal distribution table. See what is Z1? Z1 is minus 0.8. It is minus 0.8. Still you find the area of 0.8. 0.8 from the normal distribution table. 0.8. 0.8 is only the value 0.8. So you take the difference of 0. So you see in first column 0.8, 0.7881 and subtract 0.5 from this value 0.7881. Subtract 0.5 and so you will get the area here. It is 0.2881. Then A2 is the area corresponding to Z2. Z2 is 0.5. You see the area of 0.5 in when the difference is 0 because the value is only 0.4. So difference is of 0, and if we see it is in distribution table 0.4. 0.4 is here, and in the first column because difference is of 0.4, it is 0.6554. Subtract 0.5 from this value, that will be the area of 0.4, and after subtracting 0.5 the area is here. (0.1554), and you just do the addition of area of Z1 plus area of Z2. It is nothing but 0.4435. This is the probability between Z1 and Z2. And so the required number of students between 12 and 15 is equal to, now you multiply this probability by 1000 and it is equal to 443.5. 443.5 means approximately it is 443. So number of students are 443 out of 1000. Score between 12 and 15. This is your answer. Okay. Now next sub question in the same example is, how many score above 18? How many score above 18? That is to find probability of X is greater than 18. Means your X1 is here 18. Now you convert this X1 in terms of Z1. And the formula is here X1 minus mu upon sigma. Now here X1 is 18, mu is 14, mean is given here, mean is 14 and sigma is 2.5. The mean and standard deviation is same for all sub questions. Mu is 14 and sigma is 2.5. So put here mu and sigma 14 and 2.5 respectively. And here X1 is 18 because we find how many score above 18. So X1 is 18. So if we simplify it, it is 1.6. Now you find, we are finding here, we are going to find the probability of X greater than 18. It means you find the probability when Z is greater than Z1 because we have converted X1 in terms of Z1 and it is 1.6. So you find the probability when Z is greater than 1.6 because the value of Z1 is 1.6. 1.6. Z is greater than 1.6. Now 1.6 is a positive value. You draw the diagram and that 1.6 Z is equal to 1.6. Z1 is equal to 1.6. It will lie on RHS side of the normal distribution curve, and Z1 is equal to 1.6. Now we want the area when Z is greater than 1.6. Z is greater means you find the area of this shaded portion. How to find the area of this shaded portion? The complete area from Z is equal to 0 to right hand side, complete area is 0.5. This complete area is 0.5. And then from this area you subtract area of Z1, 1.6. It is nothing but the area of shaded portion. So the formula is 0.5 minus area of Z1. Area of Z1 is this blank region of RHS side. If we subtract this area from this complete 0.5 area, then we have the area of shaded portion. And so it is equal to 0.5 minus area of 1.6. Now area of 1.6, you can calculate it from the probability distribution table, normal distribution table, 1.6. You know how to find the area from normal distribution table, 1.6. This is 1.6. Difference is of 0 because the value is only 1.6. Difference is of 0, so the area is 0.9452. Subtract 0.5 from this area. 0.9452 minus 0.5, and the area will be 0.4452. So here the area is 0.4452, and if we subtract from 0.5, it is 0.0548. So this is the probability when z is greater than 1.6. It means this is the probability when x is greater than 18. Now we want how many score above 18 out of 1000 students. So it is equal to required number of students is equal to 1000 into the probability 0.0548, and it is nothing but 54.8. 54.8 means approximately it is 55. So the number of students who score above 18 equal to 55. Okay, this is the answer of second sub question. Now the third sub question in the same question is how many score up below 8. How many score below 8 means that is to find probability when x is less than 8. How many score below 8 means when x is less than 8. So here x1 is 8. Now x1 is 8 and the mean is mu is 14, sigma is 2.5 here. So you convert that x1 in terms of z1, and so it is x1 minus mu upon sigma. Z1 is equal to x1 minus mu upon sigma. This is the formula. Now x1 is equal to 8, mu is 14, and sigma is 2.5. You simplify it, and then z1 is equal to minus 2.4. The value of z1 is negative. So if we draw the diagram, that z1 will be in the LHS side of the normal distribution curve. Z1 is equal to minus 2.4. Now we want the probability of x less than 8. We have converted that x in terms of z, and so we want the probability of z less than z1, because we have converted that x1 in terms of z1. What is z1? Minus 2.4. So you find the probability when z is less than minus 2.4. Now z is here, z1 is here, minus 2.4 in LHS side of the normal distribution curve. Now we want the probability when z is less than minus 2.4, means the probability of this shaded portion, because it is less than minus 2.4. Now how to calculate the probability of this region? The area of this complete left hand side region is 0.5. You subtract the area of z1, means this blank portion of RHS side. This, if we subtract this area from this complete 0.5, we have the area of shaded portion, because the area is nothing but the probability of the required region, and so it is equal to 0.5 minus area of 2.4. Actually the value of z1 is minus 2.4, but when we find the area at that time we take it positive 2.5. We find the area of 2.4, and the area of 2.4 from the probability distribution table is 0.4918. Now you can easily find the area of 2.4. You just go to the table, go through the table of normal distribution, and you find the area of 2.4. Difference is of 0. So you will get it 0.4918. You know, every time you have to subtract 0.5 from that value. If we subtract 0.5 from the area, and the exact area is 0.4918, and this subtraction is 0.0082. So this is the probability when x is less than 8. When how many score below 8? For that, this is the probability 0.0082. And we want the required number of students out of 1000. So you multiply this probability by 1000, and if we multiply it by 1000, the answer is 8.2. Means approximately 8 students are there who score below 8. Okay. Now the next question is, next sub question is here. The next sub question, last sub question is here. How many score exactly 16? How many score 16 exactly? That is to find probability between 15.5 and 16.5. How many score exactly 16? That is to find probability between 15.5 to 16.5. Because the average of 15.5 and 16.5 is 16. So that we are going to find the probability between 15.5 and 16.5. Means here you assume x1 is 15.5 and x2 is 16.5. Now you convert x1, x2 in terms of z1, z2. So z1 is x1 minus mu upon sigma. Here put the value of x1 mu and sigma and simplify it to 0.6. And you know that x1 is here 15.5. Mu is the same value, mu and sigma, same for this throughout this example. It is 14 and 2.5 respectively. Put here the value and you just simplify it is 0.6. Then z2, to calculate z2, the formula is x2 minus mu upon sigma. x2 is here 16.5 minus mu is 14. Sigma is 2.5. If we simplify it, it is equal to 1. Z2 is 1. Now z1 is 0.6 and z2 is 1. Both are positive, z1 z2. So if we draw the diagram, z1 and z2 both lie in RHS side of the normal distribution curve. Z1 is equal to 0.6 is here, and Z2 is equal to 1 is this line. And we want the area between these two, between this Z1 and Z2. So it is nothing but the area of biggest one, means area of Z2 is bigger than Z1. So area of Z2 minus area of Z1 is nothing but the area of shaded portion. So when we find the probability between 15.5 and 16.5, we have converted that 15.5 and 16.5 means x1, x2 in terms of z1, z2, and the values of z1, z2 are here 0.6 and 1. So you find the probability between 0.6 and 1 means you find the area between 1. 1 is the big value as compared to 0.6. So you subtract the area of 0.6 from area of 1. Because both z1, z2 are positive, so we have to subtract the area from bigger one to smaller one, and the bigger one is here 1. Its area is 0.3413 from the normal distribution table, and area of 0.6 is 0.2257. From above 3 subquestions, you know how to find the area from the normal distribution table. You see the normal distribution table, there you find the area of 1.0. and difference is of 0. So the area, you will get some value. You subtract 0.5 from that value. That will be the area of 1. Area of 0.6. You see the normal distribution table. See the area of 0.6 and difference is of 0. Then you will get some value. Subtract 0.5 from that value, and that then you will get this area 0.2257. And if we subtract these two areas here, then the answer is 0.1156. We are subtracting areas because Z1 and Z2 both are positive. They both lie in RHS side of the normal distribution curve, and we have to subtract the area of bigger one to the area of biggest one minus area of smallest one. So that we have the probability between Z1 and Z2, and it is equal to 0.1156. Now this is the probability between Z1 and Z2. Now we want the required number of students score exactly 16 out of 1000. So you multiply the probability by 1000 and we have the answer 115.6. 115.6 means approximately 116. So 116 students are there.